Alright, so here we have a multiple choice question that wants us to find the period of a conical pendulum. And here are your options, A, B, C, D, and E. Here, capital T is not for tension, it's for the period of a revolution, or the time that it takes for this particular bob or mass to go one cycle. Okay, one lap, one circle. Alright, so let's go ahead and crack it out. To solve for capital T, the first thing you should definitely start with is the average speed function or speed function. Here, even though I typed out v, the velocity here is always changing for a conical system because the directions are always changing, but the speed stays the same. Right? So it's being revolved at a constant speed, but not constant velocity because the direction changes all the time. So even though here is v, really is just the speed that we're trying to find. And speed is equal to distance over time. What is the distance? The distance would be the circumference of a circle because we're trying to find the time for one period. And one period would imply that it's one cycle or one circumference. So hence the numerator circumference, which is distance divided by the time. So I'm just going to go ahead and substitute these words out for functions here. Circumference of a circle is 2 pi r. I've chosen to go with lowercase r. If you like, write capital R. Time, though, is important. I replace time here with capital T. Because the letter T here, capital T here, is the time for one cycle to occur. Okay, but you notice here, T is in the denominator, and then V here is in the left numerator. So I want to do a couple of steps here in one. I notice all these answer choices don't have an R in them, right? They all have an L, and they have theta, and then this one doesn't have a theta, but all the other answer choices have a theta. All right, so I'm going to go ahead and substitute out R here in the diagram. R was not drawn for me, but I can draw for myself. Hopefully you can draw for yourself. Here's the radius of this particular horizontal plane that's parallel to the floor. Alright, so here the angle is given touching the vertical axis, which is theta. So it's important that you pay attention to where the angle is placed for you and don't get into the habit of memorizing stuff. Okay, well here theta touches the vertical axis, so R is my opposite leg, and then L is my hypotenuse. So what I need to do is I need to use sine, because sine of theta is equal to opposite, which is R, over hypotenuse, which is capital L. Therefore, I can solve for R by multiplying both sides by L, so I can say R is L sine theta. And once I know that, I can substitute out for R, but at the same time, I'm going to move capital T up to the top left, because that's what we're trying to find, and I'm going to get rid of V by moving it to the bottom right. Okay, so there it is. So T is equal to 2 pi, which I carry down. R got substituted out for L sine theta, and then V and T are swapped. But you notice here, I don't have what V is, right? But I don't know what V is. But to find V, all I need to do is set up my centripetal force, because at the end of the day, this is a conical system. It's revolving in a circle, which hopefully should trigger centripetal force. All right. But I'm going to draw my T here. T is going to point from the mass towards the fixed point that's holding it. And then because T is a diagonal, I have a Tx, which is pointing towards the center of the circle. And I also have a Ty that's going to point up. Okay, so keep that in mind as we practice. But here, I'm just going to go ahead and use Tx, because centripetal force is the force that's pointing towards the center of the circle. In this case, it's Tx. F of c can be broken down to mv squared over r. Tx is T sine theta. It's sine because Tx here, similar to R, is the opposite leg. And opposite in this case would be sine of theta, because the angle, once again, is given touching the vertical axis. Okay, so it's a poor habit to memorize, right? Sometimes folks see Tx and they think of cosine, because in math, oftentimes x is cosine. However, the angle given this one is not touching the horizontal axis, it's touching the vertical axis. So you got to make sure you adapt and assess diagrams correctly. All right, once I have this, I can go ahead and solve for V, because V is unknown here. Here I have mv squared over r. I can multiply both sides by r and then divide both sides by m to get v squared by itself. Okay, I can substitute out r. So r, I'm going to move up to the top right, but r is just L sine theta, and then m, I'm going to move down to the bottom right. So dividing and then multiplying. All right, so I don't know what t is though. Okay, here I have sine theta, L sine theta over m. I don't know what capital T is. Now t in this case though is for tension. So if you're not paying attention carefully here, you might think this is period. This is the horizontal component of the force of tension in the string. Right, so you have a couple of capital T's here. The capital T on the left is for the word period. The capital T in this function here that I'm setting up is for tension force. All right, but I don't know what the tension force here is, so I'm going to set up the tension in the vertical direction. So watch the diagram on the bottom right. right? Because t is a diagonal pointing north, northwest in this particular problem. Tx points west, and then ty has to point up, so that's my ty. But acting against that is the weight of the mass, which I am not, I haven't drawn for you, but hopefully as you practice, anytime there's a mass, there's a weight, okay? So I can replace ty with t cosine theta, okay? Because ty is now the adjacent leg. So watch my cursor. If I go trace out this right triangle for the red line, which is t, ty is parallel to the y-axis, which is the adjacent leg. And adjacent in this case is cosine. So an f of g can be broken down m times g. And here I'm going to solve for t by dividing both sides by cosine. I'm solving for t again because in my function here for centripetal force, I don't know what the tension force is, right? But I can replace tension with mg over cosine theta. Well, here v squared therefore got substituted out. T is going to be mg over cosine, and then L sine squared theta just gets carried down. And in case you're like, wait, where's the square from? It's sine times sine is sine square. Or you can just leave it as, sine theta, sine theta. I just condense it to sine square. And the bottom stays the same. But here in the numerator, I'm just going to clean it up a little bit. You have mg times L sine squared theta, and then divided by cosine theta, and then divided by m. So I'm going to clean the numerator up a little bit. So I'm just going to say mg times L sine squared theta, and stays on the top. The cosine theta here in the numerator stays in the denominator. And then m, that's in the whole entire denominator, just gets carried down. So here I've used parentheses to point out that this is a fraction divided by a whole. So hopefully as you practice, your attention to detail is on point so that you're not going to confuse yourself with the algebra work, okay? But you notice here though, I can reduce this. I can clean up a little bit. mg L sine square theta over cosine theta over m can be rewritten as mg L sine squared theta over m cosine. This is a fraction divided by a coefficient or a variable. So therefore, you would have to multiply the two denominators. So cosine is the denominator, m is the denominator, okay? So you do not want to multiply by reciprocal here because you're not dividing by a fraction. This is a fraction divided by a denominator. So simply multiply by the two denominators. That gives you that. And here, if you realize, m cancels out. So the mass of the object cancels out. And here we have v squared is gl sine square sine square theta over cosine theta. Okay, so I'm just going to carry that down, just clean up a little bit. So I'm going to go ahead and plug it in here. But you notice here, this is t by itself, where I'm circling on and this is v by itself. But I have an expression for v squared. So you can square root this v to get v by itself. But what I want to do is I want to square this function here that I had earlier, just so that it's easy to substitute. I want to square the left side, which makes it t squared. But if you square the left side, you got to square the whole entire right side as well. So 2 squared is 4, pi squared is pi squared, L squared is L squared, and then sine squared is sine squared right here, divided by v squared. So you notice originally v was by itself, but I'm going to square it because I have v squared here. Okay, this is just a trick that I do. You don't have to. You can take the square root of v here and then substitute in. Alright, so I'm just going to carry everything down. 4 pi squared L squared sine squared theta stays in the numerator. And then instead of v squared in the denominator, I'm going to use parentheses here. I'm going to do gl sine squared divided by cosine, because that's what it equals to. Now if you notice here, things starts canceling out. Here in the numerator, you have L squared, which is L times L. So that there are 2 L's. So I'm going to cancel the square with the 1 L in the bottom. And then sine squared in the top and bottom is going to cancel out. And so ultimately, I have this expression. T squared is equal to 4 pi squared L, because that's the only thing remaining in the numerator. In the denominator, the only thing that remains in this parentheses is g over cosine. Here, you have a numerator divide by a fraction. And anytime you divide by a fraction, you have to multiply by the reciprocal. So I'm going to keep 4 pi squared L in the top, and then I'm going to multiply by the reciprocal. So the cosine theta goes on top, and then g stays in the denominator. Okay. So as you can see here, we have 4 pi squared L cosine theta over g. Now, well, this is t squared. The question, all these statements here is for just t. So to get t by itself, we use square root both sides. So this is why I think it's easier to just go ahead and square t's and then square root it later. Why? Because the square root of 4 is just 2. Square root of pi squared is just pi. And then anything that I can't square root or factor out, I'll just keep it under the radical sign, which is L cosine theta over g. And as you can see, This matches with choice B because I see a 2 pi in the front. Well, all of these have 2 pi in the front, right? At the end of the day, this has cosine, and my function has a cosine, so L cosine over G. So the answer is going to be B. All right, I hope that helps. Stay nerdy, don't be white.